You see my screen, right? And I already recorded. You see the full screen?
Yep.
Yes, good. So today we have few slides. First one about the amount of testing, which is our topic, and another thing is just few things about also documentation. We'll just see two types of documentations. So let's get started. So first, when we talk about the amount of testing, what's come to your minds, guys?
Well, it can be a lot.
What?
I think coverage
Okay.
of the code.
The number of permutation and combination of variables, whatever else factors are there.
Okay, maybe all of this is under this topic, but the main question here, maybe if it should come to your mind, the meaning of amount of testing means when I have to stop testing. When you have to stop testing. So this is the question. Maybe we try to answer it today. It's actually it's not easy, this question, because we cannot end that with the testing. We cannot say, okay, now it's enough testing. Our product is perfect now. It's quite difficult, but that's why we have some techniques, or something can help only. Something can help to evaluate the testing amount. So
I think whiskey can help to stop testing.
yes. So okay. So here the outlines, just something introduction, which is a question. Now I will give you another question, and then we will see some way to evaluate the amount of testing. As you mentioned, exactly the coverage, the complexity, also fault seeding, mutation testing, and monitoring the fault curve. So this is also some way to evaluate the amount of testing. So the main question here, and okay, this is what the outcome of this course. As you see, you should be familiar by the end of this class. You should be familiar with different methods to evaluate the amount of testing. So as we mentioned, we have some few methods to evaluate the amount of testing, and some of these I think you already know. Something like, for example, it's the sorry, I should change. Okay, then. So I think we already talked about coverage, complexity. That thing, right? And that's why we go for quick that. And then fault seeding. This is, I think, it's new, but maybe from the name, you know what's mean fault seeding. The same to mutation testing. It's under the same topics. And then monitoring the curve. I think it's okay. So this is the methods. This is the methods of evaluating the testing, evaluating the amount of testing. So now the question: when to stop testing? When? Now I can say, okay, you are in the progress. You are doing the testing. So when you have to stop? Some guys share your thought. What do you think?
Once your test plan is complete, you can stop.
Okay, this is one answer. Okay, next.
When the time is up.
When the time is up.
Yeah. Or the money is up.
Okay.
It's out of money.
Yes, the budget for this project is up.
Yeah.
Okay. Next. Okay, now
or if we set a goal in the beginning, like how much % we want to cover.
Okay, yes, exactly. This is not, I just want to say that, okay, now if we look to the function of the system, so now what we have to talk about it, the function now. For example, we can say if we test all the project functions or the system function, also we can stop. So all these guys is correct questions, correct answer. Here I have your answer, but I put it as a question mark. I mean, if you have run all the blank testing, as your one of you said, so we have to stop. We don't know. if we, for example, in terms of the functionalities, I check or I test all the function of the system, should I stop or no? Also, it's similar if we check all the white box testing, should I stop or no? Because it's a little bit different. So we have different method and this and this. Also, if you say all the time and the money, it's up. So should I stop if I have complete all this? So we say it's really quite difficult to say I have to stop or the testing process now is completed. It's quite difficult. Just I will say we have some methods that can help to say, oh, now it's maybe I can't stop, or or maybe I have to increase this the amount of testing in this module or in this module or in this area or in this area. So as we see, just we have few methods to help us. That's all. Otherwise, we cannot say we complete our testing. We cannot say that. It's difficult. It's quite difficult. So it's difficult to determine when to stop testing. Okay. Because we cannot claim that our software is completely 100% is free of bug. So here, as we say, some way to evaluate the amount of testing. Even this way, guys, we cannot say we cannot help us 100%. Just give us some information about the project. As we say, for example, let's look to the first one, the coverage measurement. Okay, this is, you know that, okay, they just give you some percentage that, okay, you compute, yeah, your test is cover all the test case or the code or the code. Even though I'm just saying, even though if you cover 100%, but still you cannot confirm that your system is free of bug. And before I go through this, I'm just saying also, even though this way also cannot confirm 100%, but it just indicate that, okay, we are in the end, we almost cover everything, but cannot confirm it's our project, it's 100%, it's free of bug. That's why we can use more than one way. We can use more than way to evaluate our project. So here, as we see, this is the list of, we have also the complexity, fault seeding, mutations, and monitoring. Maybe, you know, all just maybe these two topics. Maybe you are still new topics for you. So the first method, which is coverage measurements, you know how to, what's this, you know what this coverage measurement just is to give you some measurement that, okay, you cover all the codes or the lines or not. So maybe also it's easy now if you can use some tools, it will show you how many percent of your code is covered, how many percent of your code is covered. So this is the first methods that's help or that indicate, okay, our testing, it's or how many percentage we have finished our testing. So this is the first one. Okay, the complexity. Okay, guys, remember last time we talked about cyclomatic, right? So this is exactly cyclomatic. But okay, what the relation now between the complexity and the amount of testing? Okay, as I can tell you here. So first, you know what mean the complexity. Okay, for those who don't know, the complexity actually is just we can say is the measurement that indicate or that show the complex of your code or the complexity of your code, which part is more complex than other parts. So for example, if you have many methods, okay, and then you calculate the complexity of each methods, and then you will find there is some method, maybe it's or has more complexity than others. So what you have to do here, you will focus more on that one that have more complexity. So this is the relation between the amount of testing and the complexity. Okay, guys, means that if you have many modules, let's say we have, why it's not working? Okay, we have, for example, many modules. And then after calculate, why? Okay, let's say we have 3 modules. So after calculate the complexity, now each one has different module, a different value, different complexity. So now you can see which part of your software it's need more testing. Okay, then you will focus or you will allocate your target where you need more testing. So this is what we can say here. Use as a tool to focus the testing, also to evaluate the amount of testing based on the complexity. Okay, we have here, as you know previously, the cyclomatic complexity, which is MAC-K. This is the one we know previously, is the same, but we learned previously, and we see now in how it's work. Also, we have here holistic complexity. So this is just example that for methods that use for calculate the complexity. Okay, guys, this is the relation between the amount of testing and this topic, which is the complexity. So just it will guide you where's the part that need more testing. Also, in this topic, we have some other thing. It's the number of complexity. Now, for example, you have 1 method, okay, and the complexity is 7, for example. What's means that the minimum number of test cases should be 7. Okay, so also this is also can help for to calculate or to calculate the minimum number or to determine the minimum number of test cases. Okay, guys, this is 2 topics is related to the complexity. First one, it will guide you where your focus of testing. The second thing also is the complexity number indicate or show you the minimum number of test cases required for testing that's code, for example. We will see now one of them. For this first one, just know where's the highest place for complexity, so then you can give more attention for that part. For the second one, when we have to calculate the complexity and then we calculate or we generate the test cases, so test cases should be the minimum test cases, it's equal to the complexity number. So we will see this one, even we already talked about it, just show you a few slides about it. So, you know, guys, complexity is based on the graph. So we have number of edge and so number of node plus 2. Number of edge minus number of node minus plus 2. So this is in some cases, if there is we can use another formula to calculate the complexity, which should be the number of branch or number of decision plus 1. So actually the total should be same. The number of the complexity for both should be same. Just this is another formula. So when you use this formula, if the maximum of 2 each leave from 1 node, we have, for example, any node in the graph, the maximum number of the edge is 2. The maximum number is 2. So if 3 cannot use this formula, so you get back to the first formula. Okay, these 2 formula, either this or this, it can be used for calculating the markup complexity. So here an example. Okay, here you see the number of, we say first is number of edge, right? We have here 1 edge and 2 nodes. So 1 minus 2 equal plus 2. So the complexity is 1. So here we have number of edge. How many? We have 3 edge, and we have also 3 node. So 3 minus 3 plus 2. So this is using the first formula. We calculated here. Guys, maybe it's okay to use the laser only. Okay. So here we have, because once I click, it's show me to the next slide. So we have 3 node and 3 edge. So 3 minus 3 plus 2. So the total is 2. So using this, the first formula. If we use the second formula, which is number of branch, so we have how many decision here? We have only one node, decision node, only one, and it's come from this node is 2. So it's meet our requirement, which is, as we say, maximum of 2 edge leave from one node. If there is only the maximum edge coming from one node, it's 2. Okay, similar here. So we can use this formula, which is number of decision plus 1. So here is the number of decision, which is 1 only. The number of node, how many node meet this requirement is only 1. So 1 plus 1 equal 2. So this is using the 2 formula. So this is how to calculate the method, or how to calculate the complexity. So based on that, actually we can use it to what we can do to, as we say, okay, to determine the number of test cases. So now, for example, this is, we can say we have maximum number of test cases should be it's 1, or the number of test cases should equal to this, the minimum. I think I showed that in the maximum number of test cases requirement. Complexity or cyclomatic complexity is the minimum number of the test cases. So this is, guys, it's an example of the complexity and how it's used for our topic today, which is the amount of testing. So we have, this is the basis path, same is a model based on the graph. This is a model based on the graph. Actually, basis path, it's testing techniques based on the structure. Based on the structure of the program means that we should know the code. We should know the code, and then based on that code, we should draw the graphs. After that, we can generate the test cases based on the complexity, which that means we should calculate the test case, calculate the complexity. After that, we generate the test cases based on that complexity. And here we have to what we can say is generate, because we guys before regarding the test cases, actually we can say select or generate. Generate sometime if we use some methods, actually they call it is generate. So but if you're using manually, so we cannot say generate. You just you select the test cases. So the test cases either is generating or selecting. There should be the complexity is the minimum number of test cases. Means that if the complexity is 7, that means the minimum number of test cases should be also 7. So here is the these methods. It's used also to determine the number of test cases. That means also the amount of testing. Okay. So here the step, as we see, first we have to design the control based on this model. We have to first draw or design the control model, which is the flow graphs of our programs. After that, calculate the complexity of the program, and based on that complexity, we generate the test cases. Generate the test or the set of bad. The set of bad. Okay, guys, there is here when we say the set, generate the set of bad. So for each bad, we can say we have 1 test cases. It's the normal. If you have, for example, 2 bad, means that you need 2 test cases at least to cover these 2 bad. Now we assume that each bad have only 2 true or false, right? So each bad have 1 test cases or require 1 test cases. So this is the step or the process for this method, which is the base method or base bad testing. It's based on the based on what we say, based on the complexity, also based on the graph. So we have to generate the graphs, and this is also it's a white box methods. That's why, because here we say is structure testing, means that is we have the code and then we will generate the test cases, or we generate the complexity based on the code. We generate the test cases based on the complexity and so on, and all is based on the complexity. So here the idea is that you should select as many execution paths that's equal to the number of the complexity. Okay, this is the idea. That's why we have to link what we learn, why this is under the complexity. So we will generate, or first we will calculate the I difference. We calculate the complexity. After that, we will, based on that complexity, also now we have the path. So the number of the test cases should be, or the minimum number, because we're always looking for the minimum number of the test cases. So the minimum number of the test cases should equal to that complexity. Let's see an example. So this example actually is the triangle programs. Remember this program, we use it in exercise 4. So in this exercise, or in this program, we have 4 cases. Either it's, we have 4 cases. So we want to cover these 4 cases. So let's draw first as the step. We just to draw first the graph of this, flow graph of this program. So here we have the program, or this we have the flow. As we see here, we have, we can, I mean, if we follow up with these graphs. So here is the graph of this program. Okay, as you know, it's easy to draw this graph based on this number, and then from each node actually here is represent one instruction, and each edge is the flow from one node to another node. So here from the first step, or from first statement, which is the input, and then second statement, which is the first if. After that, we go to the first alert, or first brain, for example, which is 3, and then end, number 10. The second branch, we have input, and then we go here, but it will be false. Then we go to step 4, which is another if statement, and then go to step 5. After that, we go to step 10, and so on. So here is the graph for this program. So next we have to calculate the cyclomatic complexity. Here we have 12 edge and 10 nodes. 10 nodes. Yes, we have 10 nodes. 8 and 2, which is 10 nodes. So the cyclomatic complexity should be 4. So now we have to generate 4 test cases, which is cover all these code, which cover all the branch in this code. So this is the, we can say now, based on our rules, the number of the test cases should be 4. The number of the test cases, or the minimum number of test cases, should be 4. That cover all these test cases. And this is true in this example. We can say we have 4 branch here. This one test case is to cover this branch, another test case is to cover this branch, third test case is to cover this branch, after the last test case is to cover the last branch. So this is, we need 4 test cases to cover all these branch. So based on the cyclomatic complexity, we have 4. The complexity is 4. So, and the test cases that cover all this branch also it's 4. So let's see now another example. So here, okay, this another example. We already have the graph. So based on that example, based on this example, the complexity here is 7. So we need, based on our rules, we need 7 test cases to cover all these branch. We're talking about the branch, it's not the path. So, but we can say that this rule is not always true. This rule is not always true. So we can have, for example, 4 test cases to cover all these branch. Because we look, if we see here, we have this first branch, right? And then we can go from the same, and then this is the second branch. So here we cover 2. That's why we need 1 test cases for cover the first branch, second test case to cover the second branch. And then here we go to we do the same. So we need 4 test cases to cover all these branch. So based on the case, it's not all the cases, it's same, but at least the cyclomatic complexity can estimate the number of the test cases, And the same thing here also, we can say, even if you select 7 test cases, maybe also you cannot reach either statement coverage or branch coverage. So in all cases, you have to select the test cases carefully. So we have another method, which is error-based testing. This is also, it's helped to evaluate. We will learn 2 methods. The first method is to, for example, to evaluate the test quality or the test suite, for example, quality. You already generate the test cases, so how is the quality of that test cases? Okay. Also, the other methods is to evaluate the testing process. Is your testing process good enough or not? So here we have 2 methods. Okay, as we said, the first method is the error seeding. First, okay, what's the error seeding? Actually, you add some errors in your app. Not you, actually, should be if you are the tester, so should be your manager or your developers add some errors in your application, and then give you without telling you that I add some errors. And then you will test your application normal, but if you catch that errors, means that your work it's well, or your test cases it's okay, or the process. No, here the process. That's why we say the first one is to evaluate the effectiveness of the test process. So the first method, just as we say, is not that difficult. No, even some theoretical or some calculations. Just no, there is some calculation to calculate the errors. Okay, just this one to evaluate the testing process. Okay, the idea, as we say, or the manager or the developers add some errors, and without telling you there is errors. And you test or you go through the testing process normal, and then if you catch that error, it means that the testing process goes well. So the second method, which is mutation testing. Mutation testing actually is you generate many versions of your applications. The tester, okay, not the manager now. Generate many versions of the code, of your source code. For example, you have methods for calculate many things, and then you generate, or you can say we copy many, or we can say we clone these methods, or we create many versions of this, and each versions have a problem, or we can say change something, small things, or we make a small change in that code. So now we have the original code, and we have another code, which is another versions of that code. And each one is just, there is a small change. And this change, we call it is seed, or we call it mutation. Each one have small mutation. Now, guys, so you know what's mean mutation? Mutation is small change, is abnormal things in your code. Actually, this is, if you go to genetic, its mutation means that there is a small change, for example, in the human body. That means is mutation. That is coming from that term. Okay, this one, a mutation is good. It's used for evaluate the test cases. Why here? Evaluate the test process. So this is actually more about the fault seeding, maybe, as I was just saying. But okay, what we can say here, it's need more works. Sometimes if maybe sometime you will forget the error or the fault in your programs and need to change. Okay, no problem. So here, guys, how to calculate, because guys, you receive the application with some fault. You will receive the application with some fault, so you need to calculate. Not you need, maybe later your manager should compare how many fault you detect and how many fault they add. So this one also can help you to predict how many real fault in your application. Real fault, okay, means that there is some, we can say it's seed fault, as they mention here. For example, why is the seed fault, which is added to your application? It's added to the code. Some fault, it's added to the code. Okay, and then there is some, okay, of course, there is some real faults. And then here, now once you do the testing, you will find some fault. And your manager should know this is, okay, this is the real fault or this is the seed fault. Of course, they will know. So there is some, this formula can help to calculate the real fault based on how many fault you find. How many fault you find is just a simple formula. We have, for example, here, it will, is the real fault divided by, which is the founded real fault. How many fault you found should be the real fault is divided by the founded real fault. And so here in the other side equal to the seeded fault, okay, divided by how many seeded fault you find. So this formula actually can help us to find how many real fault we have in our program. So also it's kind of testing amount, how many fault I have there. So for example, now if I calculate, I mean, if I found after the testing process, I find, for example, okay, these methods, based on this method, it's maybe we can say we have 10 fault. So I found only 9. So I can say, oh, I still need to do more testing. So you see how we come from. That means we can evaluate the amount of testing using this formula. So here is an example. For example, we have 10 faults are seeded in your application. 10 faults are seeded. In the testing, 4 seeded faults are founded. So we have here 10 fault, it's seeded. After testing, we found only 4 fault of these seeded fault. So this is, and are found, seeded fault are founded, and 6 real fault. Okay, using this formula, if you see here now, we have this formula. We can say we have now the real fault should be 15. The real fault should be 15. So it means that if now I got, for example, after I complete the testing process, I got only 10, means that I have to add more test cases to find this 15 fault, which is real fault. And as we say, guys, this is just predict. I mean, maybe it's not correct. But at least this is give you some information that, okay, we have how many real fault we have. Okay, guys, do you understand this idea? Just something you will seed it, and then based on that, you will find how many seeded is founded and how many real fault is founded, and then based on this formula, you can predict that, okay, maybe we still have another fault, which is real fault. So this is actually, as you see, one methods to evaluate the testing. If you, for example, find the 15, as we say, we can say, okay, maybe now is our our program is free of bug. Maybe it's not 100%. So this is error seeding. So the second one, which is the mutation, as we see, the different now there is just, it will add it some fault and then without telling you. But here you will generate many versions of your application, and then based on that, you can use even some tools, or you can run your test cases, run the same test cases in each version, and then check how many. Okay, if you detect that's error, if you detect that's fault, that you make it. So means that you kill it. So your test case is okay. If you don't detect that's error or that mutations, means that you need more test case. You need more than this case. So here, this is okay. Maybe later you read it. This is what I just told you. Okay, here is the test cases. Focus on the measurement of the adequacy of the test cases. So this is the quality of the test cases, the effectiveness of the test cases. Okay, as you see here, is not testing strategy. Means this will not help you to generate the test cases. It will not generate test cases. It will not generate test cases just to evaluate your test cases. It will evaluate only your test cases. So that's why you should use it with another traditional testing methods. So here I'm just telling you, you will generate test cases. You will generate many versions, and then you will apply your test cases, the same test cases in all these versions. And then if your test cases detect that's shrink, that mutant, we call it, so means that you kill that mutant or that mutations. If not, that means your mutations still survive. So you have to add another. Therefore the test cases should be updated. Means should add some more, or even you just update it only. Update means maybe you just change another test cases, it will cover all, or you add one test cases. So whatever that means you need two more test cases. So here the process, what's the mutation process? We will create many versions. After that, we'll do the testing the same. We'll apply the testing, the same testing. So if the mutation or the mutant is alive, means that we need more test cases, and then we back again to do the same testing. Otherwise, it's good. This is the process. This is the process of mutation testing. So how we can do mutations? Mutation means what the operation, what the sentence that I should to change. Okay, guys, before you can use some methods. You can use some method here. Maybe I have to write. It's not, so I have to use the pen. One method which is very popular. If you Google it, you will find in Google a lot of videos, which is bit test. This is one method that help you to generate the test cases, to do some mutation. You just upload your not upload. Maybe you can even use it in Eclipse or use it from the command lines. So it's a bat file. So here it will do some mutation in your code. After that, it will apply the test cases and then show you the report. But you have to know how it works, because you are a tester here. You study this course, so you have to know how this tool works. Means what kind of method or lines should be changed. So here I will just give some about that. So okay, guys, anything in the code can be changed, anything. But here we change always. Okay, for example, for example, if statement. We change the input also. We delete some result. So let's see now how we can do some mutation in this code. We have this code, just simple code. If x greater than y, then max is y. If else y max is x. Okay, just find the maximum number between two numbers. So here the first one we can just think, for example, this operation. So this is mutation. Okay, this is mutant. Not mutation. Okay, we can say mutation is both is noun. So the second thing, maybe okay, we can just delete one sentence. We can, for example, we have many if else, we can delete one else. Okay, this is mutation. We can double the operation here. We can double the operation. For example, it was less than, I say less than or equal. So this is all. It's how to mutate the program. So this is the first one. For example, we just see here from greater than, we will keep it less than. So here more information about that. Even in the operations, we can change. We can, for example, only just replace one. For example, it was y greater than, right? It was y greater than or x greater than y. We can change one by constant. This is also another options. We can change any one of them. For example, I change replace x and y. Here, the first one, the first mutant, just replace x and y. It was x, it's greater than y. I just change to y greater than x. This is another options. I replace one by constant. Also, this another options. You can replace the other one by. So this is one options. Okay. So here is the second one related to the expressions. We can, for example, it was greater than, I change to equal, greater than or equal. Okay, equal, and then plus increase one operation. This is the increase operation. So this is how we can do mutations. Also, we can delete some sentences. As I told you, we have, for example, if print something, else print something, so, or else if print something. So now, for example, we have 3. Delete one of them. Delete one statement. Delete one statement. So any delete one return, delete anything, delete something. This is also mutations. Okay, guys. So this is all about mutation testing. As we see, we have the program. We change something, and then we apply the same test cases. If the test cases catch this change, so that means we kill the this mutation or this mutant, and then our test cases is okay. Otherwise, we have to edit our test cases to kill that mutation. So this is the last methods. Now, okay, for example, you finding, which is now it's the curve, error curve, monitoring the error curve. This is to monitor, to evaluate the test cases, not the test cases. Evaluate what, guys? Evaluate the amount of testing. The last method, which is monitoring the curve. For example, every time you apply your test cases, you will find that, okay, now I find only a little fault. And for example, in the beginning, I find 10. Okay. After that, I find it's increased to 11. After that, it's increased to 12. Sorry, 12. And then maybe after 12, I feel it's the same. Now it's no change. 12. Whatever I do, I change the test cases. I add new test cases, but okay, the curve is go straight. So this is also, we can say, okay, now maybe it's enough testing. So this is the last methods where we see is not method, just okay to check your test cases or the progress of the test cases. Okay, guys, this is the last methods.